Hey Math 3, it's Miss Robertson, and I just wanted to review the quadratic formula with you. Remember, quadratic formula is used to solve quadratics. It's one of the methods that we have to solve. Remember, we can solve by factoring, we can solve by graphing and looking at the x-intercepts, we can solve by using a table and looking for the zeros. And sometimes our solve, which means find the solutions, right, also is called finding the roots. So these are all the strategies we have, and quadratic formula is just one of them. Quadratic formula will always work. Factoring and graphing, using the table might not always work, because remember, sometimes our quadratics are all the time the quadratics make a parabola, but sometimes they don't hit the x-axis. So if they don't hit the x-axis, our solutions are imaginary. So then we really need the quadratic formula. We also can solve using square root property. Sorry, I almost forgot that one. Okay, so y'all know I can't sing. But you also know that I love all of you. So I will sing if it helps you. There are YouTube videos. If you don't want to hear my voice, just fast forward this part. But I learned it to Pop Goes the Weasel, like the little one that you like crank up and the Jack in the Box pops up. So negative b plus or minus the square root of b squared minus 4 times ac all over 2a. If you want to hear it again, you can rewind it. Again, you could fast forward it, but that's what helps me. So when I write it, and the next thing I would like you to do, this is the honor system, is 5 times just write this down. So if I were you, like when I write it, I would say x equals negative b plus or minus square root b squared minus 4ac all over 2a. However it helps you. Okay, so I hear you guys can't really see when I write on the paper, so I'm going to do these 4 examples on the board. The first one is 2x squared minus 4x minus 30. You do want to make sure it's set equal to 0, and then you're just going to find your a, b, and c. So a is 2, b is negative 4. Make sure you grab the sign in front, and c is negative 30. So x equals negative b, so negative 4, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's a lot. I want to take this under here. This is actually called the discriminant. It's called the radicand because it's under the radical. But in quadratic formula, this b squared minus 4ac tells me the type of solutions I'm going to have. So if it's greater than 0, it's going to be a real solution. If it's equal to 0, then it's going to have a multiplicity. And if it's less than 0, then it's going to be a negative. So that means we're going to have our imaginary. So I'm just going to put that in my calculator because that's probably the easiest way to do this. Make sure you put parentheses here. So when I do it, negative 4 squared minus 4 times 2 times negative 30. So that tells me my discriminant is 256. So negative 4 is positive 4 plus or minus the square root of 256 over 2 times 2, which is 4. I'm going to just check that 256 is a perfect square. If it's not, then I would have to reduce that radical, but I recognize that the square root of 256 is actually equal to 16. So my next step, I'm going to have 4 plus or minus the square root of 16 over 4. So the square root of 256 is 16. So 4 plus 16 over 4 and 4 minus 16 over 4. 4 plus 16 is 20. 20 over 4 leaves me with 5. 4 minus 16 is negative 12. Negative 12 over 4 is negative 3. All right, hopefully you guys are still with me. Let's try number 2. So number 2 is 8x squared plus 4x minus 1. A is 8, B is 4, C is negative 1. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, again, I want to figure out what this discriminant is. This is a square root. It's kind of getting messy. I'm sorry. So I'm going to do, if you know 14 and 4 squared, you could do 16 minus 4 times 8 times negative 1. Okay, or you can be really careful and just put it all in. Notice I'm not putting the square root in though. I'm just putting what's underneath, which is called the discriminant. So that gives me 48. 48 is not a perfect square because I know that 49 is a perfect square. And I can check in my calculator, 2 times 8 is 16. I can check in my calculator by doing the square root of 48. That's going to give me a decimal. We don't want decimals, we want exact. So now I need to break down square root. Square root has a 2 here, so I'm going to look for pairs of 2. It doesn't matter how you start this. So I might see that 48 is 4 and 12. 4 becomes 2 and 2. 12, 2 and 6. Cross them out probably as you go. 6 is 2 and 3. And I'm looking for pairs of 2. So 1 2 comes out, another 2 comes out, and then I have the square root of 3. 2 times 2 is 4, square root 3. So to simplify the square root of 48, I get 4 square root 3. I'm going to plug that in instead of this negative 48 here. And now I'm going to look to simplify. So this radical is different. It's almost like a variable. So I don't need to look to simplify that. I just want the outside numbers. So I know that 4 goes into 4, 4, and 16. So I'm just going to divide each of them by 4. So my answer here is negative 1 plus or minus 1, or just the square root of 3 over 4. I didn't break this one up here because I had this square root. So it didn't really help to break it up. But this is still 2 solutions, which is great because a quadratic has a degree of 2, so it should have 2 solutions. All right, hope that helps. Okay, number 3. So we have 2x squared minus 2x plus 5. So a is 2, b is negative 2, and c is 5. So again, you're just going to plug it in. Negative b plus or minus the square root of b squared minus 4 times ac all over 2a. So negative negative 2 is a positive 2. Some songs actually say opposite of b. I should have told you that before. Now we're going to just put all of this discriminant in our calculator, or if we really wanted to, I'm sure we could do it out by hand. It's not that complicated because it's all integers, but negative 2 squared in parentheses, negative 4 times 2 times 5. That tells me that my discriminant is negative 36. So negative 36 is in the radical. As soon as I see that it's negative, I should automatically be thinking that I'm going to have an I, because nothing squared is negative. If I have 2 squared, it's positive 4. If I have negative 2 squared, it's still positive 4. Everything squared is positive. So the idea that I have a square root of a negative is imaginary. So there's going to be an I. So now I just need to realize that this is going to have an I. And the square root of 36, 36 is a perfect square. If you did not realize that, you could break it down to 6 and 6, and you would see that there's a pair of 6s to come out. Or you could even break it down to 2 and 3, and you take the 2 out and then the 3 out. Any way you look at it, this is going to have a 6 that comes out. So I write that as 6i. There's nothing left in here. There's just a 1, and the square root of 1 is nothing. So that goes away. And then I just want to bring down the rest. So I have 2 plus or minus 6i divided by 4. Now I just want to simplify that. So I'm looking at all 3 numbers. 2 goes into all 3. So I'm going to divide each by 2. Sorry, 2 divided by 2 is 1. 6 divided by 2 is 3. 4 divided by 2 is 2. London, out of here, please. 1 plus or minus 3i over 2. Or I could write it as two separate solutions, 1 plus 3i over 2 and 1 minus 3i over 2. So that is the answer. Again, if you want to rewind, I think this is the part that most kids have trouble, is reducing that radical. There are videos to simplifying radicals, but basically you just need to find a pair that goes into that. And anytime you see a negative, remember the square root of -1 is just I. So anytime you see a negative under a square root, you're going to have an I. Okay, let's look at number 4. So number 4 is 3x squared minus 4x plus 7. So A is 3, B is -4, and C is 7. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Again, a negative 4 is really just a positive 4. Oops, I didn't put my A in for that. Sorry. 2 times 3 is 6. So I can simplify those. And then I want to use my calculator or use my brain to figure out this discriminant. So the discriminant is going to be -4 squared minus 4 times 3 times 7. Again, I'm not putting the square root in my calculator. I'm just doing everything else. So that gives me -68. So that negative right away tells me there's going to be an I. So this negative tells me there's going to be an I. And then I want to break down 68. 68 is not a perfect square, right? And I can check by saying the square root of 68, which would be very different than the last one, which was the square root of 36. That gives me evenly 6. I'm sorry, that light helps you guys see, but when it's directly on, I know it messes it up. So 68 tells me that there's a decimal there. So I need to break this down. Any two numbers that go into 68. So I might just start with 2 and 34. All right, 2 is prime. It doesn't break down anymore. 2 and 17. Now I have all primes. Square root means I'm looking for a pair. So I have a pair of 2's. When they come out as 1. This 17 didn't have a pair, so it's left in there. So if I was looking at breaking down the square root of 68, I would get 2 square root 17, because this comes out as 1, 2, and then that 17 didn't have a pair. This one was actually -68, so when I bring it over, I'm going to slip in that I, and the I always goes after the whole number and before the square root. So this is 2I square root 17, and now bring down the rest. So that was 4 plus or minus over 6. Now I can look to simplify the outside numbers. Remember, the radicand, the one inside, doesn't get simplified. So again, all of these numbers are even, which means 2 goes into them. 2 goes into 4 twice. 2 goes into 2 once. 2 goes into 6 3 times. So I could write my solution as 2 plus or minus 1i. So just I square root 17 over 3. Or if I wanted to, I could split them up so that I can see the two solutions. Either one is acceptable. All right, Hawks, I hope that helps. I will see you in class.